Okay, in this problem, we want to determine an Euler path that begins with the vertex A. And when we're finding an Euler path, what that means is we're going to go through every edge exactly once. So remember, for Euler, it's every edge that you go through exactly once. And then in the next section, you'll see a Hamilton path where you go through every vertex exactly once. So with the Euler path, you can repeatedly visit a vertex, but you can only go through every edge once. Okay, so let's see how to do this. They actually already started the problem for you. They gave you the first 4 vertices. They gave you A, C, E, and A. So I'm going to go to the next page where we can see an enlarged version of the graph, and we'll talk about how to do that. Okay, so here I have the graph, and let's see. We've already started at A. Oh, can't see that too well. Let's see. Okay, so we're going to start at vertex A, and that was our first letter, and then they went to C. So I can go down or up, and I believe in the graphic, let's see if I can, oh, no. All right, so I believe they went down. So we're going to go through this edge, and I just like to kind of scribble on it so I can see that I've already used that edge. And so we went to C. So I'm going to keep track of the vertices on the side here. And then the next edge was E, or sorry, the next vertex was E. So I go to E and I scribble out the edge from C to E. And then back down to A. And now that was the beginning that they gave us, and those are the edges that are used. So now I need to see what else to do. I'm going to go to vertex C next. What you just want to make sure is that you don't wind up with some vertex that you can't get back to. So since there's only one more edge going into C and then an edge coming out of it, I'll go ahead and use up vertex C, and then I don't have to worry about that anymore for the problem. So let's go to C. So now, I'm going to change colors here. So now the part that I'm doing is in blue. The part that they started is in red. So I went from A to C here, and now from C I have to go to D. Now this is a little strange, the way they have this set up. And what's strange about it is that you have these points, these points here, and that it doesn't mean that there's a vertex there. There's only a vertex where there's a big dot and then a letter pointing there, so, or next to it. So, so just keep that in mind. It's not really meaning anything. You could have a curved line going from vertex D to vertex B or what have you, and they just happen to do it in kind of a polygon shape, probably because how they constructed the graph here. So now I'm at D. Now I have 2 choices. I could go to vertex B or I could go to vertex E. And I'll go to E. Kind of use that up. So I like to kind of fill in one part of the graph so you can see the right-hand side has been filled in and the left-hand side we still need to get to there. So we went from D to E, got that on my vertices, and now I have to go to vertex B. I don't have a choice. I have to go on this edge and go to B. And now, let's see. Well, if I go from B to D, this is where you have choices and one of your choices is bad. So far we really haven't had to do too much choosing because either it didn't make a difference or there wasn't a choice. So now I have a choice, and if I go from B to D, then I'm stuck and I can never fill in this B to A back to B. So I definitely have to go from B to A, and I'm going over. Doesn't really matter in this case. I'll just continue the vertices listing here. And then A to B, so that's A back to B, and now B to D, and that is the end of that. So now I have the whole list of vertices, and I can see that I've filled in my entire graph. I've traveled through every edge, and so we're good with that. Now, one more thing I want to show you. So I'm going to erase all of this. Oop, is it not erasing? There we go. I don't know why it's coming back. There we go. All right, so now my graph is clean again. What you can do to start off the problem is check the degree of each of your vertices. So vertex A, we have 1, 2, 3, 4, 5 edges that are either going into or coming out of vertex A. So A has degree 5. And then vertex B, I'm going to check all of the vertices the same way. And this little method of marking the edges as you go around, either clockwise, counterclockwise, doesn't really matter, that can help you to keep track of what have you counted already, because it's easier to get confused on this than you probably think. And then C, 1, 2, 3, 4. Okay, so C is 4. E is 1, 2, 3, 4. So there we go. And D is 1, 2, 3. So notice that you have an odd vertex in A and an odd vertex in D. So that tells you that you have to start at one of those vertices and end at the other. And since the problem told you to start at A, you know that you're going to have to end at D. So the fact that we got D as an ending vertex, that's very good, and I feel confident of my answer. It's not perfect. I don't, know for absolutely certain, but it does seem like that is correct. And the fact that we made sure we went over all the edges, that should be very reassuring as well. So that's how you do that problem.